Okay, guys, let's solve the problem about shape factor. So, in this problem, we are asked to determine the shape factor for the rectangular section with a width of b and a depth of h. Okay, so this is just a simple problem. So, we have here a rectangular section. And the neutral axis is defined by always by dividing the area. Okay, so that's the general rule on trying to find the shape factor. Okay, so always divide the area into two equal parts. Okay, so that's your main objective. Okay, so if this is a rectangle, then there's no sweat dividing it into two. Okay, so if this is your base B, this must be simply what your height, no, over 2. This is your total height here. Okay, so if I want to get your shape factor, I need to find Z or and S. Okay, so remember that my C is defined in terms of Z over S, or simply MP over MY. So, yun lang naman ang formula mo. Pero mas mahirap gamitin ito, but you can use this, no? Kesa dito. Okay? So, if you want to use this, you just include the Fy term. If you want to use this, you just go over your formula, your notes. Ito lang siya, no? Z is simply your y times the area. Okay? So, ito lang yung formula mo. Okay, so the area, if you divide it by 2, is a simple b times h over 2. So, this will be your area at the top and equal to the area at the bottom. So, if this is the area at the top, it's the area at the bottom. So, it's simply equal to 1/2 your base times height. And your centroid is simply uh, defined in terms of h over 4. Okay, so here and also at this side you have an h over 4. Okay, so you simply make use of this formula YDA summation. So since this is symmetrical, a top is equal to a bottom, then you just multiply this by 2 and multiply the area with that of the y bar. You get this bh squared over 4. And this is just a recollection of what you know or learned on your strength of materials. No? So you simply recall uh, that S is simply equal to bh squared over 6. So this was gotten or obtained from the formula S is equal to I over C. Okay, so here your I is simply bh cubed over 12 divided by your C, which is equal to h over 2. So if I cancel that, so and 1 here and there, so you get simply a bh squared over 6. Okay, so upon dividing now the value of Z and S, okay, so I get 1.5. So this is now my shape factor, and this is a good factor, no? So, but the problem is for steel design, this is a rectangular steel is actually uh, an inefficient section. No? Why inefficient? Because it is costly, although it is it is good, no? But the inefficiency lies from the fact that if you have a rectangular shape, your moment of inertia can only be limited to a certain degree. If you try to increase the width and the height, you come up with a very expensive section. So although the shape factor is good, we can say that a rectangular section is a costly section and therefore inefficient. So for the shape factors or for the efficient shapes in steel design that we normally use the W sections or the I sections, okay? And for strong axis bending, we again try to uh, use similar procedure. We can come up with an average value or recommended value of the shape factor equivalent to 1.12. Okay, and that is for strong axis bending. For weak axis bending, you have 1.5. Okay, this is again done neglecting the effect of the weld. And again, if we look at this is again a good a shape factor, but it is just like a rectangular section. It is inefficient. Okay, why? Because if we will look into a weak axis buckling and we neglect the the web. Okay, so if I neglect this web here, so I will just come up with two rectangular shapes. Okay, parang meron lang akong magkahiwalay na rectangular shape, and this is the same as that on the rectangular sections we derived earlier. Okay, so parang rectangular din siya. So it is good, but it's not a very efficient section when it comes to bending. Okay, so this is the problem, the first problem discussed here in your lecture, which is all about the shape factor. Thank you.